Hello, welcome back to Pre-Calc. This is a video over Unit 9, and we're going to be talking about analytical trigonometry in this video. In Section 1 today, we're going to be talking about evaluating the 6 trigonometric functions. So our objectives today, we want to evaluate the 6 trigonometric functions for angles in degrees or radians based on one or more given trigonometric function values. And we want to evaluate the 6 trigonometric functions for angles in degrees or radians given a point on the terminal ray. Okay, so what I want to do is take a look at this picture here and just kind of gather a picture of our ability to evaluate this. Okay, now what I want to do is we're given this point here on this ray. Okay, we have our endpoint is at the origin and we're going out in this direction. We have this angle T here, okay, but what I want to do is draw a triangle to connect this point to this point. So I want a horizontal distance and a vertical distance. Now, in my horizontal distance, that's going to be my x value. My vertical distance is my y value, okay? And that's how we get those points on a graph. Horizontal distance, vertical distance. And then I want to label this as my radius r, okay? Which is also the hypotenuse of our triangle, okay? So what I have here, and what I want to look at in order for us to evaluate this, I want to find cosine of angle T, okay? And what that's going to give me, remember that cosine is your x value, okay? But because we're dealing with a radius r here, we want to do the adjacent side divided by the hypotenuse, which is going to be x over r, okay, in this case. Okay, if I wanted to find my sine value, sine of t, remember sine is your y value, but we do the y value divided by your radius, okay, whatever your radius is. So that's going to be y over r. We want to find tangent of t, and that's just going to simply give us the opposite side divided by our adjacent side. So given this angle t, opposite side is y, adjacent side is x, okay? And so given our triangle, that's how we figure that out, okay? Now we can also do the reciprocal trig function, so I can do secant of t, all right? And that's simply just going to be the reciprocal of what I got for cosine. So that's going to be r over x. If I wanted to find cosecant of t, that's the reciprocal of my sine function, so that's going to be r over y. And then if I wanted to find cotangent of t, then that's just the reciprocal of my tangent function, so that's going to be x over y, okay? And so that's generally, what we're doing when we have these, okay? So what I want to do is take a look at something and say, all right, well, what if it's not over here? What's going on over here? And I wanted to find all trigonometric functions given this point on my graph, okay? Angle T is this big angle here, okay, that is more than 180 degrees. And we have this point, negative 15, negative 20. Now, what I want to do is come in here and again, draw my triangle, all right? And the reason why is because, in this, I know that my x value is equal to negative 15. I know my y value is equal to negative 20. What I don't know is my radius, okay, which is also the same thing as my hypotenuse here for r. Okay, now, but what I can do, because I have a right triangle, I have a friend. And my friend, we all know his name, is Pythagoras. Man, I hung out with Pythagoras a lot this weekend. I don't really want to dive into what happened, but let's just say that Jim didn't hang out with me. And the only person I could hang out with was Pythagoras. Okay, but what I have is this triangle. Okay, I have an x component, which is negative 15. Because we're dealing with a triangle, I'm just going to label this as a length of 15. Same thing with my y value. The y value is negative 20, but because we're dealing with a distance component, I'm going to call this a value of 20. Okay, and we're going to find r. Now, what I want to do over here, and I'm just going to do it right here, is I'm going to write out 15 squared plus 20 squared is equal to r squared. okay? So 15 squared is going to give me 225. 20 squared is 400, and that's going to equal r squared. So 225 plus 400 is going to give me 625, and that's going to equal r squared. So what I can now do is I can take the square root of both sides, and so I get that r is equal to 25. So I have that value, okay? Now what I'm going to do is use my values that I got for x, y, and z, or x, y, and r, to evaluate my 6 trigonometric functions. Now the first one that I'm going to do is I'm going to do cosine of t, okay? And then I'll do sine of t, and then I'll do tangent of t. All right, we'll do those because those are pretty easy, and then we'll do the reciprocal trig functions, okay? So for cosine, remember that's x over r, okay, up here. So I'm using this idea here. Now you can still just do, you know, adjacent over hypotenuse, but you want to make sure that you're using the negative values. I know that I put these positive values in here. That was just simply for me to find my radius of this circle, okay? So x over r, so we had negative 15 over 25. So negative 15 over 25. Sine is going to be y over r, so negative 20 over 25. And then tangent is going to be, what was it, y over x? So negative 20 over negative 15. Now, what's interesting about this is that each of these ratios can be simplified. So I'm going to divide each of these by 5, and so this is really going to simplify down to negative 3/5. This one's going to simplify down to negative 4/5, and this one's going to simplify down to positive 4/3. Okay, so now that I have my generic trig functions, what I can now do is I can label my secant function. Secant of t is just my reciprocal, which is negative 5/3. Okay, I can find cosecant of t, which is the reciprocal of my sine function, which was going to be negative 5/4. To find my cotangent of t, then that's just going to be the reciprocal of my tangent function, which is going to be 3/4, and that's it. Okay, so okay, so the next thing I want to talk about is this thing called a Pythagorean identity. Now, here's what I've got here. I have this identity that claims that if I take sine squared theta plus cosine squared theta, then that's going to give me a value of 1. Okay? And so here's what I know. You know, let's do this. I'm going to come in here, and I'm going to draw in my right triangle. Okay? Now, here's what I have. Here's my angle theta. I'm going to call this length here A, this length here B, and this length here C, okay? And the reason why I'm going to do that is because I know that my friend, who I spent a lot of time with this weekend, claims this, that if I take A squared plus B squared, I get C squared, okay? That's the Pythagorean theorem, all right? What I want to do is show you why this whole thing works here, okay? And let's do this. First thing I want to do is let's talk about just sine of theta. So sine of theta, let's do cosine first. So cosine of theta is given my triangle here is my adjacent side divided by my hypotenuse. So that's going to give me A over C. Okay. If I were to find, say, sine of theta, that would be B over C. So given theta, this is my opposite side divided by my hypotenuse, so I've got B over C. Okay, and what I want to do is use this idea here to prove the Pythagorean theorem. Okay, so this is the Pythagorean identity, and it works. We're using the Pythagorean theorem here, but that's the idea. All right, so what I want to do is do this. If I do sine squared theta, so sine, let's just write this out. Sine squared theta plus cosine squared theta is equal to 1. Okay, the first thing is, when you write sine squared theta, what you're really doing is you're taking sine of theta and you're squaring it. plus the quantity cosine theta, and you're squaring it, and that's going to equal 1. Now, the reason this is just a formality. When they write sine squared theta, they just put the squared there. So you remember this step is really important to go from here to here, because you'll see sine squared theta quite a bit. And I'm going to put that down as just sine of theta quantity squared. All right, so now what I want to do is replace sine of theta with its ratio from this triangle, which is just b over c. So if I do this, I'm going to do b over c quantity squared. Plus, I'm going to replace cosine theta with a over c. So this is going to be a over c quantity squared, and that's going to equal 1. Now, if I have a fraction and I'm squaring it, then I can square my numerator and square my denominator. And same thing over here. I've got a squared over c squared, and this is all going to be equal to 1. Now, the next thing that I want to do, okay, is understand that I've got a common denominator between c squared. So I've got that b squared plus a squared over c squared is equal to 1. Now, if I wanted to get c squared out of my denominator, what I could do is I could multiply both sides by c squared, and oh man, look what happens. The c squareds divide out, and look what I have. I've got b squared plus a squared equals c squared. Wait a minute. I could just switch these two, and I could write a squared plus b squared equals c squared, and boom! That's the Pythagorean theorem. So, I know this is weird. I know this is strange, and it's really cool at the same time. But what we have to understand is we have this thing called an identity. It's the Pythagorean identity. If I take sine squared theta and add it to cosine squared theta, I get a value of 1. Okay? In our unit circle, we have a radius of 1. Okay? And so I'm going to use this concept to... And the reason why I'm showing you this, not only is it an identity that we need to know, because we're going to use it further on in this unit, but we can also use this idea to solve and find our trig values the same way that we did over here, okay? So I'll show you how to do that using both ways. One is easier, one's a little bit more complex, but you can use that, all right? So on the next page, we have Pythagorean identities, but we can also develop other Pythagorean identities, and we're going to do that on the next page, all right? So this is just a me way to show you how freaking cool this is. By doing a little proof. So this is a proof, and I just showed you why this works, okay? But on the next page, we're going to develop some other identities, and we'll go through that. All right, so turn the page. Okay, so what I want to do, I want to develop the Pythagorean identities. All right, so we have the first one, okay, which I know to be sine squared theta plus cosine squared theta is equal to 1, okay? Now, what I want to do, that's my first one. My second one, and it doesn't matter which order we go in, but I'm going to write that same identity down. So I can develop this at any time. So you don't have to memorize these, but you do have to, go through it. So here's what I got. What I'm going to do is I'm going to divide every single term by sine squared theta, okay? And when I do that, what that's going to do is I can simplify this. And if I take sine squared theta divided by sine squared theta, it's that something divided by itself, it's going to give me a value of 1. Plus, now if I do cosine squared theta divided by sine squared theta, now cosine divided by sine that's going to be cotangent theta. So I'm going to write cotangent squared theta. And that's going to equal 1 over sine squared theta, which is really just cosecant squared theta, okay? So this is another Pythagorean identity, okay? And all I did was I took my original Pythagorean identity and I divided everything by sine squared, okay? And that gave me that. So I can use that as well, all right? The third one that I've got, I'm going to write out my original sine squared theta plus cosine squared theta is equal to 1. And I'm going to divide everything by cosine squared theta. Okay? I should have done this one first, but whatever. All right, so now if I have sine squared theta divided by cosine squared theta, sine divided by cosine is going to give me tangent. So this is going to be tangent squared theta plus 1 is equal to 1 over, not 1 over secant squared theta. This is just going to give me secant squared theta. Okay, so that's my other Pythagorean identity. So I've got these 3 identities that we can use, okay? So, we'll use them as need be, but, that's we'll kind of go over that more so in the next few sections. Okay. Now, using the identities to find trigonometric values. Okay. So what I can do is I can do this. Given that sine of theta is equal to 4 over fifths, and theta is in between pi over 2 and pi, find the remaining trigonometric values. Now, I'm going to do this the easy way first. Okay. What I'm going to do, given this, I'm going to come over here and I'm just going to draw a picture because we're going to need some room to do it the other way. Okay, I'm going to draw my, my unit circle over here. Okay, and what we're dealing with is a value of theta that's between pi over 2 and pi. So I have this quadrant here that we're dealing with. Okay, so sine of theta is equal to 4 over 5. And what I'm going to do is just draw, think about that angle. I'm also just going to draw a generic triangle in here. All right, so start at my origin and opposite over hypotenuse. So I'm just going to draw a generic triangle. Okay, I'm not trying to find the angle measure, but here's what I know. I know that this value here is a value of 4. I also know that my hypotenuse is 5. Okay, so using just my generic values. Okay, I know that that's the case. I know that my radius is always going to be a positive number. My y value is positive. Okay, but we're in the second quadrant. So what I know, and we can kind of do Pythagorean theorem on this again, is I want to find the x value here, okay, of this triangle. And so what I can do is I can write this out as x squared plus 4 squared equals 5 squared. X squared plus 16 is equal to 25. I can subtract 16 from both sides, and so I get that x squared is equal to 9. And then take the square root, and I get x is equal to 3. Now that's the value of this side of the triangle, okay? Because we do have a right triangle. Let me make sure I label that as a right triangle. However, if I'm trying to find the coordinate point, then I know that my x value has to be negative, okay? And so that's what I'm doing in calling it that. So this is the point negative 3, 4. And now we're back to what we had before, all right? So here's what I know. I know that x is equal to negative 3. I know that y is equal to 4, okay? But I also know that my radius is equal to 5, okay? And so what I can do is I can then figure out all my values, okay? Now, just knowing that, okay, knowing those values, what I can do is I can write out, sine of theta is equal to 4 fifths. I know that cosine of theta is equal to negative 3 fifths. If I wanted to find tangent of theta, then that would be negative 4 thirds. Okay. If I wanted to find my reciprocal functions, then I can just do, let's start with cosecant since we started with sine. That's going to be 5 fourths. If I wanted to find secant of theta, then that would simply just give me negative 5 thirds. If I wanted to find cotangent of theta, then that would simply give me negative 3 fourths. Okay, so we can do it that way. And that would be how I would do this normally. However, we can use our Pythagorean identities to do this as well. Okay, so I did it this way because I think this is quite a bit easier and more intuitive, but we can also use the Pythagorean identities. So given that sine of theta is equal to 4/5, we want to choose, I'm going to choose sine squared theta plus cosine squared theta is equal to 1. Now I'm going to do this. I'm going to do sine of theta squared plus cosine of theta squared is equal to 1. So I'm going to change it over to that. Now what I'm going to do is I'm going to substitute in sine of theta, 4/5 for sine of theta. So watch what happens here. I'm going to do this. I'm going to do 4/5 squared plus cosine of theta squared is equal to 1. Now if I take 4/5 and I square it, then I can get that, what is that, 16 over 25 plus cosine of theta quantity squared is equal to 1. I'm going to subtract 16/25 from both sides. Okay, so now I have this. I have that cosine of theta squared is equal to 1 over 1 minus 16 over 25. Now, I'm going to get a common denominator, so I'm going to multiply the top and bottom by 25. So cosine of theta squared is going to equal 25 minus 16 over 25. 25 minus 16 is going to give me 9 over 25. Cosine of theta squared, I'm going to take the square root of both sides, okay, to isolate my cosine value. So then I get that cosine of theta is equal to plus or minus 3 over 5. Now what we have to figure out is, because cosine, remember, is your x value, and because we're dealing with quadrant 2, that means that the cosine value for this is going to be negative. So we can discover that cosine of theta is equal to negative 3/5. So I can use the Pythagorean identity to do the exact same thing that I did over here, okay? This requires quite a bit more algebra. This one doesn't, but you will end up with the same thing. So I typically try and use the triangle, but you can also use the identities to do so, all right? So go ahead and get started on your assignment and quiz, and we'll talk to you soon. Thanks a lot. Bye!